everybody. My name is Jun Hanzhou, and today our team will introduce our final project for DSC I501. And our topic is about COVID-19 cases, and we chose 5 datasets from Kaggle, which is the data sets shown above. And as the guideline says, we need to do 3 tasks to complete this project. And the first one is to build an EDFS system. And first of all, I will go with the Firebase system implementation and MySQL implementation demo. And here you can see this is our Firebase terminal, and this is all the command you can type in. And let's start with make a directory. Let's see, you make a user John, and here you can see there's a directory named John, and also you can type in user gear, and of course there's two, and let's type list user, and you can see gear and John both here. And now we can put some data into it, like the puts with partition. And here we go. We have day-wise under June, and you can see in the Firebase system here, there's directly June and gear and day-wise, and there's a day-wise with partition 3. And of course, you can put more with other partition number, like the for group 1. File not found. Oh yeah, there we go. And you can see in the Firebase system, there's 4 groups with 4 partition. And of course, you can read the partition. This is and since we have 3 partition, if you type 4, that's now, and you can just get all those, not the single partition, but the entire. You can see, of course, you can get the location of the partitions. Here is the stuff, like you can type in this, yeah, normally what we got here. And you can also remove from the file it under John the day-wise, and there's no day-wise here. Okay, now goes into MySQL implementation. Basically, is a function the same as my as Firebase design. And let's get started with make a directory. Still user John. I submit it, and you can see this user and the John, and we can do Alberta and submit is here, and let's list the user. You can see Alberta and John, of course, and let's put some stuff in it. Put still day-wise and submit. You can now we can get the partition location since it's implemented with MySQL. I did it's put in another 3 table with 1 table for 1 partition, so we get there was 1 to 3. And now we can read the partitions, and like take an example. Yeah, there's 1 single stuff for that. And you can see in the MySQL part, you can show the tables, there's day-wise and day-free and directory. If you selected all from parts, you can see the base is day-wise, and there was 1 to 3. And if you check the directory, you can see here there was in June, of course, basically the same. And if you try to do the remove function, of course, successfully removed and just John at Alberta. And yeah, I think that's pretty much what I want to say. And next goes to my another partner for that. Thanks.
Okay, so I did the Firebase EDFS and the MongoDB EDFS implementation, and I will just talk about how it looks like and how my code basically working. And so here, the Firebase database. So since it's a cloud database, so basically just get from the website and push to the website. So here is our my data structure. So here we store the directory, one we call the make directory, and the put. So if you simply put a make directory slash user slash Alberta, you just get this. And also, if you put the file, you will just store the file name under in the file, uh, just the file name. So under the directory, and so that you can find it. Basically, a kind of metadata. And in the metadata, it's explicit give you the location of the partitioned the file. So this is the file, this is the path. And all the all the other files are our data sets. Let's take a look. So it's partitioned, and those are our data. In my MongoDB, basically it's pretty similar. So, but MongoDB is a local database, and so in my MongoDB, I only create a database called data, and put all the actual data, file data, and the metadata collection all under the data database. So the metadata collections are these three: directory, file, and partition. So a partition and file are pretty simple. The partition just give you the file name and the partition number, like the order. Number 0 means the first one, yeah, simply. And the location, the data dot the file name, which means uh, the it's under the database and the daywise collection. And the file, more simpler, just the file names. So the directory of MongoDB is a little different from Firebase. So whenever you make a directory and put a file, it will just insert one document. So it will just insert one. Since the ID is different, so the other attribute might be duplicate, and I will talk about a little bit more on when we go to the code. So in my Firebase, make URL and a correct dictionary to push this directory to the Firebase. So basically, just call this function and pass through the input, the user input. You will get a new, like a part of the URL, but it's basically created by user input, the actual path, and also the dictionary. So in the MongoDB, I need to create the database and the collection first, and also instead of creating a URL, yeah, I need to actually create the dictionary. Since every time I make a directory or put the file, it will insert one document into the collection. In make directory, just call the function, and then you get the correct dictionary, and you insert it in the listing. So listing is quite different, since there's probably some duplicate attribute. I do a search first, which using this find query, and you get the corresponding all the attribute under that pass, and then you just again call the function and get the correct dictionary. And in the remove, there's probably some duplicate, not actually duplicate, but except the ID is different, other thing is the same thing. So I need to delete all of those. So I use delete many, and then drop the actual data, the data collection. Unlike the Firebase, it's not using the cloud, so that's probably the difference. And get location and repartition pretty much similar things. You just get the collection under the database, and you get the exactly like the explicit partition under the corresponding collection.
Hi everyone, my name is Hang Zheng, and my responsibility in our group is to implement the analytics function. And I have designed 3 programs, and for solving those 3 programs, I implemented the partition-based map and reduce on data stored on 3 EDFS, Firebase, MyCircle, and MongoDB. Also, we implement the partition-based map and reduce by Spark. Now I will talk about the 3 programs in detail. This is our interface of our project, and you can see through the navigation, there are 3 analytics implemented through 3 different EDFS, that is Firebase, MyCircle, and MongoDB. And now I will take the Firebase as an example to show the 3 analytics program. The first problem is that which continent has the most total cases of infection and which continent has the fewest total cases of infection. I use this query to get this table. This table shows the sum of total cases grouped by continent. And we can conclude from this table that North America has the most total cases of infection. And Oceania has the fewest total cases of infection. As for map and reduce in this case, map partition take world matter data in partition P and output the sum of total cases for each different continent. The reduce function then combines the sum of total cases in. The second problem is that how do new cases and total cases of infection grew from January 2020 to July 2020? And I use this query to get this table. This table shows the total of new cases and the total of total cases grouped by the date. And we can conclude from this table that from January 2020 to July 2020, the number of new cases increased from 9,000 to 6 billion. And from January 2020 to July 2020, the number of total cases grew from 38,000 to 362 billion. In this case, the map partition takes a date-wise in partition P and output the sum of total cases and the sum of new cases for each different date. And the reduce function combines the sum of total cases and the sum of new cases in. Now let's look at the problem 3. The problem 3 is that what is the death rate from the COVID-19 in each country and region? Which countries and regions have the highest death rate from the COVID-19, and which countries and regions have the lowest death rate from the COVID-19? I use this query to get a table. The table shows that the death rate of every country and region. We can conclude from this table that over the 187 countries, these countries and regions had the highest death rates of more than 10%. And these countries and regions had the lowest death rate at only 0%. As for the map and reduce in this case, map partition takes a full grouped in partition P and output the sum of deaths and the sum of comfort for each country or region. And the reduce function then combines the sum of deaths and the sum of comfort in. Finally, calculate the death rate for each country or region. Now I can show you about the MyCircle analytics. It's very similar to the Firebase analytics. And this is about MongoDB analytics. Okay, that's all about the analytics. Thank you.
So, okay, now I'm going to talk about how our data analysis running on EC2 machine using PySpark. First of all, we need to import the PySpark to create Spark context, and then we read the file and creating the RDD. And for the program number 1, you can see that we use the mapping and sorting. After that, we get the exact same results as we do our own map reduce and partition. And of course, for the analysis too, you can see it still shows the same result for January, and for July is basically the same result. And for our analysis 3, it's take a little bit time. You can see based on our analysis, and they are the same.
Hi everyone, I am Yuwen Yuan, and I am going to introduce you guys the search functions that I implemented for these projects. So the first function, for here, I use the dataset countrywide latest.csv, and I implemented the function map partition that takes partition P for each country in the partition and then check if its price is in the search range or not, and then I'll put the country name if yes. And for the second function, and here I use the dataset COVID-19 clean complete.csv, and here I implemented the map partition function that takes partition P for each country in the partition and then check if its price is in the search range, and then output the country name as well as the region if yes. So next I am going to talk about the coding part. So right here you can see the first function that I implemented, and this is the Firebase version. So right here, this function, the first function, is where we extract data from Firebase, and then the next function is the map partition function that takes in the input, and here the third function is where we takes the value from the web app to get the result. And right here we have the second function, the function that I implemented, and it is used to search for COVID-19 clean dataset. And right here is also the function that I use to handle Firebase database, and then the map partition function and the get result function. And then I have the other implementations like the MySQL implementation right here. And the only difference is the first few lines where we handle the data extraction from MySQL database, And we also have the MongoDB implementation right here. And the only difference is also the first few lines where we extract data from MongoDB database. And right here, I have the implementations by two functions on the web page. So these are the three database implementations that I have. And right here, we enter the range of the confirmed cases from 200 to 1,000. And then we click submit. And here are the results of the countries between 200 and 1,000. And then we have our second function that search for death cases. And we search for cases between 200 and 500, and then we click submit. And here are the countries, including the regions. So right here, we have those countries, and for China and Canada, we also have the region included in the range. So the MySQL implementation is basically looks the same, and we search for cases between 100 and between 100 to 500. And right here is the MySQL implementation for the second function, and we search for cases between 300 to 400. And here is the result. And also we can see that for Canada, we have Ontario as well as Quebec in the region. And right now we have the MongoDB implementation just as before. And we also search for 100 to 150. And right here, we have the second function for MongoDB. And then we search for 3,000 to 350. And the results are right here. We can see that there are also Ontario and Quebec including this. And that is it for my search functions. Thank you guys for watching.
Hello, everyone. This is Anna, and my job is to combine all the functions of our teammates implemented and created the web browser-based app. So for the whole design, we implemented front-end and back-end separately. In the back-end, we use Python Flask, and in the front-end, I'm using Vue 3 and Element Plus, which is a framework and ecosystem that covers most of the common features needed in the front-end development. The first thing I think I need to consider is how to make it intuitively and user-friendly. So creating a menu and sub-menu here, you guys can see it. It's much more easy for people to route all of our pages, and breadcrumb navigation to help user easily route to the needed page like that one. Even that can help us to cross the limit of menu and sub-menu. And I think the next thing I need to conquer is to connect with the back end, since my whole teammates have designed the backend in Python Flask, and the data format needed to be sent have been decided. So, which includes JSON and form data format. Here is a code I'm trying to implement it. Like in the script function, you guys can see it. Take the file browser for example, which in our previous elaborate, you guys can see it is like a tree implement. Here is the dog of the element plus, and it looks like this one. So the feature is that we need to send an attribute of array list. But for the data we get from the backend is actually a JSON file. So we need to convert the JSON to array data, which is defined here, and push the data we get from the backend to the data defined here, which is array, and we can just call it through element plus tree implement. Once we click the button, like the show in the doc previously, we can get the result we need. And since we need to get data from the backend, it may come across a very big problem is that we will cross different regions. So in the backend, we simply use actions to add this line here. No, the cross, simply add this line here. You can get, it can help people to accept all the router from the front end. And in the front end, we use actions, which is a way to make its cross-region connecting works. And we can get the data from the backend. So like in this one, in this EDFS implement, simply since the data we get from the backend is actually the form data, and we need to send it through form data. So once we click the submit button, you guys can see it is here is the submit button, and we need to let the form data be appended and call the poster we need to send and post the data to the backend. And we can see it here. We get result from the backend, which is a post one. And next thing I think is analysis. Here is the table of analysis. It's actually a JSON file we get from the backend. So in the implementation of data connecting, like this one, we simply still use fetch data. Once we create the page, we call this function called created and fetch data from the initialize of the backend. The more detailed implement is here. So this way we can fetch data once we click the button here. You guys can see it. And for the search page, it's look like here. It's obviously the same kind of implement like before, since we send a JSON file or format data in the backend through the to the front end.